This is video number 5 for sections 7.4 and 7.5, the discriminant. So if you think about the three problems that we worked in the last video, they were all quadratic equations, but in each case, something different seemed to happen. In the very first example, we ended up with two real solutions. They were kind of messy solutions, but they were just normal real number solutions. In the second example, we ended up with one real number solution only one solution. And then in the third example, we ended up with no real solutions. We had complex solutions. Well, the question being asked here is, what part of the quadratic formula decided that? Why is it that one of the problems came out one way and the other one's another way? Well, if you go back and look carefully, you can probably figure that out. Think, for example, about that middle example. Why was it again that there was only one real solution here? It was because when we worked out the square root number, we had a zero. And since this was a zero, the whole plus or minus part went away. Or think about the third example. Why did we end up getting that I thing in the third example? Because of the square root number. Since it was negative, that's what led to the I. In the very first example, the one that came out, I suppose, the most normal, well, why did that happen? That happened because the number in the square root was just a nice positive number. Nothing funny happened. We ended up with two solutions. Well, let's see if we can summarize that information. So what part of the formula determined how many and what kind of solutions we got? It was the number inside the square root. Well, we call that number the discriminant. In other words, d, the discriminant, is equal to the b squared minus 4ac. It doesn't include the square root itself, it just is the number inside the square root in the quadratic formula. And based on those three examples that we did in the last video, we figured out if the discriminant is positive, if it's just a nice normal number, I think ours was a 20, then you're going to get two real solutions. If, on the other hand, the discriminant came out exactly equal to 0, like the middle example, well, then that whole plus or minus part went away, and we ended with only one real solution. The final possibility would be that the discriminant number, the number inside the square root, comes out negative, comes out less than 0, and that's when we had no real solutions. Or another way you could say that last one is we ended up with two complex solutions. The discriminant basically gives you a way to know what kind of answers and how many answers you're going to get without actually having to find the answers. So if you take a look at this sample problem, it says don't actually solve the equation. Just figure out how many answers you're going to get and what type they're going to be. Well, all I have to do is calculate the discriminant, use this chart, and I will know. This equation is already in standard form. It might not be a bad idea to list out my A, my B, and my C. 3.1, -4, and 2.17. I don't have to calculate the whole quadratic formula, just the discriminant. The slots are probably still helpful. Just slot squared minus 4 slot. A B gets placed in the first slot, that's -4, and then an A, I'm glancing up at the discriminant, and then a C. Calculator will probably be helpful for that last part. I have 16 for this part, only one minus, so it's going to stay minus. And then I'll grab the calculator for 4 times 3.1 times 2.17. I got 26.908. If I then subtract, this comes out to be -10.908. That's the value of my discriminant. Well, according to this chart, if your discriminant comes out negative, which this one did, that is a tip-off that you have no real solutions, or too complex solutions would be another way to say it. So even without solving this equation, I know that I would get two I answers if I was actually going to work it out all the way. Of course, if you wanted to actually find the answers, you'd have to go ahead and use the quadratic formula.